Hey, very good afternoon all my dear friends. So, today we are going to deal with biomolecules and polymers. Two chapters. These two chapters are really very important. These two chapters are very scoring chapters my dear friends. So, definitely today I am going to tell you each and everything from the very basic, right? So, my dear friends, biomolecules, the chapter, if we talk about carbohydrate chemistry, most of the students, they find difficulty. They are getting confused in the structures of, if I talk about starch amylose, amylopectin, alpha D glucose and beta D glucose and mutarotation, like all these things. My dear friends, first of all, just let me know, just do let me know in the chat section, am I audible and visible to all of you? If yes, my dear students, just do let me know in the chat section, am I audible and visible to all of you? If yes, just show me the thumbs up in the chat section. How's the Joes, my dear students? Just do let me know in the chat section, am I audible and visible to all of you? Yes, my dear students. If I am perfectly audible and visible, just let me know in the chat section. Yes, my dear students, I'm waiting for your response. Just show me the green signal if I'm perfectly audible and visible to all of you. Yes, my fantastic, fabulous army. Definitely very fantastic, my dear students. Now, what I'm saying, I'm going to start with biomolecules, and today, definitely, I will let you know each and everything from the very basic. And, my dear student, who is the hero of this chapter? Glucose. Just like organic chemistry, and we are dealing with carbohydrates, biomolecules, my dear students, this glucose is the instant source of energy for the patients, and this glucose is the hero of this chapter. My dear students, if we are able to understand the clear structure of glucose, that means 80% of this chapter, that the carbohydrate chemistry, will be in our brain, my dear students. So, we have to understand each and everything about glucose. So, are you ready, my dear students? Just do let me know in the chat section, are you ready for this, the glucose? Till that time, let me give you a very brief about myself. I am Harendra Singh Parihar. You can call me HSP. I did MTech in 2004 from HBTI Kanpur. After qualifying MSc in 1999, I am the gold medalist. I did my GATE and GRF qualified. After qualifying GATE and GRF, I completed my MTech in 2004. But my dear student, let me tell you, this chapter is very important. Glucose, what I was talking about, glucose is the backbone of this chapter. And let me tell you each and everything from the very starting about the glucose, then the disaccharide, then the polysaccharides. I will let you know each and everything from the very basic. My dear students, this is the structure of glucose. But let me come to this structure. See, my dear students, CH double bond O, CH2OH. My dear students, this is the carbon number 1, and this is 2, 3, 4, 5 and 6. This is the Fischer projection formula. Fischer projection formula. According to Fischer projection formula, this straight vertical line, this is your parent chain, According to Fisher projection formula, this straight line, this vertical line is our parent chain. According to IUPAC, this is going to be the parent chain. My dear students, this is the last carbon. And if I talk about this HOH, these two OH means on the fifth carbon, this is the second last carbon and this is the last carbon. If two hydroxyl groups are on the same side, we will call it capital D. My dear students, we will call it capital D. Remember that this capital D has nothing to do with dextro. Capital D has nothing to do with dextro, that is small d, that is the plus sign, dextro rotating, because small d is just experimental concept. This glucose we have got dextro rotatory. Experimentally it is found that this glucose is going to be dextro rotatory. In the lab with the help of spectrophotometer they got this is dextro rotatory, so plus sign, and this is glucose. Now let me tell you here H, OH, H, OH, and at this position this is the third carbon H, OH. This OH has to be on the left hand side. My dear friend, just see to it, this OH is on right hand side, this OH is on right hand side, this OH is on right hand side, and this is also on right hand side. Only this hydroxyl group is on left hand side. Remember that on the third carbon this OH will lie on the left hand side. Is it clear to all of you or not? This OH should lie at left hand side, rest of all the OH are on right hand side. Now this is D means last and second last carbon OH are on the same side. This positive means experimental it is dextro rotatory, and this is glucose. Now let me tell you my dear students once again the structure of glucose. So this is CH double bond O, this is CH2OH, this is CHOH, second CHOH, fourth CHOH, and on the third carbon this OH is on the left hand side. 1, 2, 3, 4, 5, 6. These two are on the same side, that's why it is capital D. 1 chiral carbon, 2 chiral carbon, 3 chiral carbon, 4 chiral carbons. That means there are 4 chiral carbons. So if somebody is asking glucose is optically active or optically inactive, my dear students, this glucose is optically active, and total number of optically active isomers 2 raised to power 4. That means 2 to the 4, 2 to the 8, 2 to the 16. That means 16 optically active isomers are there. For glucose, we are having total 16 optically active isomers, and this is known as open chain structure. This is known as open chain structure. Now my dear students, you can see very clearly this carbon is being sp2 hybridized. That means this is oxygen, this is having delta negative, then this carbon is having delta positive, and this carbon is having one pure p orbital. One pure p orbital means it is having 2 lobes, one on the right hand side, another one on the left hand side. Now my dear students, this oxygen is having delta negative and delta positive. So this oxygen is going to attack on this carbon. This oxygen will attack on that carbon from the right hand side as well as from the left hand side. Now question arises, why only this oxygen? Why I am talking about this oxygen only? Why I am not talking for all rest of other oxygens? This is the main point to be noted, my dear students. This oxygen, if this is going to form bond with this carbon, you will get 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon and 6th atom, 6-membered ring. You are going to get 6-membered ring. Six-membered ring. Remember that 6-membered ring is highly stable than 5-membered and then 7-membered ring. This is the stability of ring, and later on I am going to tell you this is going to form pyranose ring structure. My dear student, this is going to form pyranose ring structure. So let me tell you its cyclic ring form, that is the pyranose ring structure. My dear students, see, if I draw, this was the glucose, open chain structure of glucose. Remember that this 3rd carbon OH is on the left hand side. So what I was talking about, we have to keep in our brain this oxygen which is attached on 5th carbon. This is the main oxygen. This is going to be a game changer. This is going to attack on this carbon from the left hand side as well as from the right hand side, and that is going to form ring structure. It's aqueous solution, that is reversible reaction. See, this oxygen is going to form bond with this carbon also. This is permanently of this 5th carbon, but this is going to form a bond with 1st carbon also. Are you getting my point? My dear student, just do let me know in the chat section. Are you getting my points? This oxygen is going to attack from the right hand side. This oxygen is going to attack from the left hand side because this carbon is being sp2 hybridized, and sp2 hybridized means this carbon is being trigonal planar with 2 lobes of one pure P per P or B pure P, which is perpendicular to the plane of paper. So definitely it will attack from right hand side, it is going to attack from the left hand side, from both the sides, my dear students. Now see what I am going to get. I will get COH, H, and this is our 5th carbon. This oxygen, this is going to form bond with this. Now see my dear students, this is your 6th carbon, 6th carbon, this is your 5th carbon. 5th carbon was forming a bond with this oxygen, was forming a bond with this 5th carbon only. Now it is forming a bond with 1st carbon also, my dear student, 1st carbon also. Now see, this is 2nd carbon, this is 3rd carbon, this is 4th carbon, this is 5th, and this is 6th. Now my dear students, the 1st carbon OH and the 3rd carbon OH, they are on opposite side. This is the point which we have to keep on our brain, that the 1st carbon and 3rd carbon OH are on opposite side. This and this are on opposite side. So we'll say alpha D positive glucose. Are you able to understand why we are saying this is alpha? Alpha means the 1st carbon OH and the 3rd carbon OH, they are on opposite side. That's why we are saying it is alpha. Now my dear students, if this OH, this oxygen which is having negative charge is attacking from the left hand side, we will get another compound that I am going to tell you. See, COH and the 5th carbon, this is 5th carbon, and this is your that same oxygen, the 1st carbon and the 5th carbon, and here is the 6th carbon, this is your 2nd carbon, this is your 3rd carbon, this is your 4th carbon. Now my dear students, just see to it, 1st carbon and 3rd carbon OH are on the same side. That remember this point, 1 and 3. 1 and 3 are on the same side, we will call it beta D glucose, beta D positive glucose. So you have seen one thing very clearly, one is alpha D glucose, another one is beta D glucose. My dear students, are you getting this point very clearly, that glucose exists as open chain structure and closed chain structure. In the closed chain structure, we have got ring of 6 atoms. 1, 2, 3, 4, 5 and 6 is the oxygen. We can call it, see, what do you call it? So see how many atoms are there. Just check it out. The number of atoms 1, 2, 3, 4, 5, 6. Total 6-membered ring. Out of these 6 atoms, one is being oxygen, heterocyclic ring, and this is known as pyranose ring structure. Pyranose ring structure. And this bond is formed, this bond is having OH group and this oxygen, you can say hydroxy ether of aldehyde. That is hemiacetal pyranose ring structure. That's why it is known as hemiacetal pyranose ring structure. Hemiacetal pyranose ring structure. Now, my dear students, one thing is very clear that it was having 1 chiral, 2 chiral, 3 chiral, 4 chiral. Now, this carbon is also chiral because in the open chain structure, this carbon was not chiral carbon, but in closed chain structure, in the hemiacetal pyranose ring structure, this is 1 more chiral carbon. So, 1, 2, 3, 4, 5. So, in the ring chain structure of glucose, we are having total 5 chiral carbon. That means total number of optically active isomers will be equal to 2 raised to power 5. Are you getting my point, my dear students? Total number of optically active isomers are 32. So, in aqueous solution, we are having glucose as open chain structure, closed chain structure, alpha D glucose, beta D glucose, and alpha D glucose and beta D glucose. If I talk about what's the relation in between alpha D glucose and beta D glucose, my dear students, alpha D positive glucose, beta D positive glucose. In the aqueous solution, they are interconvertible. They are changing one into another. We can say this is reversible and they are in equilibrium. My dear students, this conversion is known as mutarotation. This interconversion is known as mutarotation. So, in the aqueous solution, we are having alpha D glucose, beta D glucose as well as the open chain structure of glucose, where the oxygen which was attached with the 5th carbon is forming a bond with first carbon. The first carbon is known as anomeric carbon. So, these two are, what's the relation in between these two? These two compounds are anomers. If I say this is X, this is Y, so X and Y are anomers, and remember that all anomers are epimers, and all epimers are diastereomers. My dear students, anomers, epimers, diastereomers means alpha D glucose and beta D glucose are epimers as well as diastereomers, and this interconversion is known as mutarotation. And if I talk about what's the optical rotation of this alpha D glucose, so optical rotation is 112 degree and it is 18.5. So, if I put alpha D glucose in the aqueous solution, that will try to convert into beta D glucose, and if I put beta D glucose in the aqueous solution, that will try to convert into alpha D glucose, and at equilibrium they will have the value of 52.6 degree. This is the question of your NEET exam. Number of times this question has been asked, what is mutarotation and what is the value at equilibrium. So till now, if everything is clear, just to let me know in the chat section so that I can move ahead, my dear students. Just to let me know in the chat section if till now if it is clear to each and everyone. What are epimers? I will let you know what are epimers. My dear students, just show me the thumbs up if each and everything is clear. Do like and subscribe, my dear students, if everything is clear. Just to let me know in the chat section that you are able to get it. Yes, it's your channel only. Just make it clear. Show me in the chat section that everything is very much clear to all of you. If each and everything is perfect, just to let me know in the chat section that yes, you are able to understand. And my dear students, likes must be get increased. Yeah, naming reaction part 2 definitely I will give you, but first let me know in the chat section that everything is very much clear. Anomers meaning, I will let you know what's the meaning of anomer, what is the meaning of epimers. See, my dear students, epimer means if any monosaccharide is having different orientation of hydroxyl group, OH group. This is hydroxyl group. Epimer means if any monosaccharide is having different orientation of hydroxyl group only at one carbon, then we will call it epimer. Then we are going to call it epimer. For example, glucose and mannose are being epimer. Glucose and galactose are being epimer. Just let me show you the structures of see, everyone just try to focus on these three structures. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. CH double bond O, CH2OH common, CH double bond O, CH2OH common, CH double bond O, CH2OH common. Till now in these three structures, let me call it A, let me call it B, let me call it C. Till now they are same. Now let me put HOH, HOH, HOH. Till now they are having everything common. HOH, HOH, HOH. Now we know very well this is being glucose. This is being glucose. This too we know very well. This is being glucose. Now HOH, HOH, HOH. Let me tell you what's the difference in between the first and second structure. I would like to understand it from your side. Just do let me know what is the difference in between A and B. First of all, you just let me know at which carbon do you find difference in between, yes, this A and B? On which carbon you are getting difference in between A and B? Just let me know, my dear students. Yes. Are you getting my point? Just try to find out where is the difference between A and B. So yeah, definitely your answer is, yes, your answer is at second carbon OH is on the right hand side, and here the second carbon OH is on the left hand side. Rest of the things are really same. So here is one surprise for you. Just guess who is here, my dear student. Just try to find out who is here in this room, who is going to come. I welcome. Yeah.
What's up, guys? What's up? How's the Josh? I'm so glad, guys. You guys are killing it. So involved in the chats. Wonderful, giving proper answers. I was just seeing your video, right? Like, this is a great involvement from the students as well as your God of Chemistry HSP, sir. So, people, how is it going? Is the Josh high? I want the Josh to be high. Yes, it has to be high. So, let me know quickly in the chats. How is the Josh? Everyone, guys, everyone. The chat box has to be flooded. Kill it. Let me know. How is the Josh? Josh is supposed to be high all the time. There are only 10-12 days left. So, please and please, make sure the Josh is high. Yeah? Right? Wonderful. And there is one more surprise which I'll be letting you know. Maybe tomorrow or day after tomorrow. Right? That is going to be a special surprise for all the NEET 2023 aspirants. So, as I promised, everything will be taken care of. And absolutely, we'll be taking care of every single thing over here. Yeah? Perfect. I can see the fire symbols.
Wow, Josh is
wonderful,
really very
wonderful,
high.
guys, wonderful.
Fantastic.
I would want you guys to keep it up, and please take a note of every single thing. Whatever HSP sir is teaching right now, take a note of every single thing, because every single thing is really, really very important. Okay? It is pure content based, short, crisp, precise, right? So these are the most expected topics as well as the questions which HSP sir is taking care of for all the NEET 2023 aspirants. So take a note of every single thing properly, okay? And I would see you guys tonight at 8 p.m. with 2 chapters. That is going to be solid state and states of matter. So 2 chapters tonight I'll be doing with all of you. Take care. God bless you all. Continue, sir.
Okay, thank you, sir, Fugami. Okay, thank you, sir. Now, my dear students, just try to find out what's the difference between the first compound A and B. You will come to know that OH here is on the right hand side and this compound OH is on the left hand side. Now, so definitely they are difference. They are finding difference only at one carbon, that is on the second carbon. So, are you ready, my dear students? Come back. Are you ready? So, this is glucose and this is being mannose. This is being mannose. Just to try to find out nose. Here is one trick. Nose is always on the upper hand side. See here, nose is over here, up. Nose is nose. If the difference is on second carbon, this will call as nose. And now see, try to find out HOH. Now, my dear students, in between A and C, what's the difference? What's the difference in between A and C? So, definitely you will find out the difference is over here on the fourth carbon. So, the difference is on the fourth carbon, my dear students. So, just try to find out the glucose, the fourth carbon OH was on the right hand side and here the OH is on the left hand side. So, these two are also, A and C are also what? A and C are also, yes, my dear students, A and C are also, yes, epimers, and this is known as galactose. So, galactose, here is the trick for galactose, my dear students. Gal, in Hindi, this is gal or gala, right? This neck, gala, galactose. Nose is on the upper side and gala is on the lower hand side. So, if the difference is on the upper hand side, we will say nose. if the difference is on the fourth carbon, see 1, 2, 3, 4, 5 and 6, fourth carbon, if the difference is on fourth carbon, we will say galactose. So try to understand what is galactose, what is mannose and what is glucose, my dear students. So these two are what? These two are epimers. And A and C is also epimer, but B and C is not epimer. Why? B and C is not epimer because they are finding difference at 2 carbons. So my dear students, let me tell you, glucose and mannose, they are epimers. They are your epimers. Glucose and galactose, they are epimers. But my dear students, mannose and galactose, they are diastereomers. They are diastereomers. They are diastereomers. Now the question arises, alpha D glucose and beta D glucose, they are also finding difference on the first carbon. So glucose, mannose, glucose, galactose, they are epimers as well as diastereomers. They are epimers as well as what? Diastereomers. So now the question arises, can we say that all epimers are diastereomers? But all diastereomers need not to be epimers. Just to let me know in the chat section. If this statement is true, then just let me know in the chat section what I am saying. All epimers are diastereomers, but all diastereomers need not to be epimers. Just to let me know in the chat section, is this statement is true or not? Just find out true or false. What I am saying, all epimers are diastereomers, but all diastereomers need not to be epimers. Just to let me know in the chat section this statement is true or false. I am waiting for your answer. Just to let me know in the chat section this statement is true or false. Yes, my dear students. Absolutely correct. Absolutely correct. This is 100% true. This is 100% true. Absolutely correct. Absolutely correct. Now, the question arises, what are anomers? Right now, everything is clear in your brain. What are epimers, what are diastereomers, and now let me tell you what are anomers. Anomers. If the OH orientation is different at the carbon involved in hemiacetal or hemiketal formation. So in the form of fructose, I will let you know what is hemiketal, but in case of glucose, I have told you what is hemiacetal carbon. That was the carbon having oxygen at fifth carbon that was forming bond with first carbon. That was the hemiacetal carbon. So alpha D glucose and beta D glucose, They were just anomers, anomers, anomers. So example of anomers is being alpha D glucose and beta D glucose. Why they are anomers? They are anomers as well as they are epimers and they are diastereomers. They are all three because they were having just a difference in OH on the first carbon. That first carbon was involved in ring formation. Are you getting my point? So alpha D glucose and beta D glucose, they are epimers. They are epimers as well as they are anomers and they are diastereomers. Now question arises again this word is coming, diastereomers. What are diastereomers? Now my dear students, let me tell you what are diastereomers, because these are very basic concept which should know, otherwise we can't do the carbohydrate chemistry, because carbohydrate chemistry is having lot of stuff of stereochemistry. Now my dear students, what are diastereomers? Any guess? What are diastereomers? Can you please let me know what are diastereomers? All those stereoisomers which are not mirror images of each other. What I am saying, my dear students, all those stereoisomers which are not mirror images of each other are known as diastereomer, or simply I can say all those stereoisomers which are not enantiomers are diastereomers. Is this thing very much clear to all of you? Now see, my dear students, let's move to glucose. This is your glucose, and glucose ring formation I have told you. Now the most important thing about glucose, that we should know the Hayworth representation. This is the basic thing. Once if you know the Hayworth representation of glucose, then you are going to kill this chapter, because 80% of carbohydrate chemistry is based on this Hayworth representation only. So are you ready for the Hayworth representation? Just do let me know in the chat section that everyone is ready for Hayworth representation. I am going to draw the Hayworth representation. My dear students, just to let me know in the chat section that you are ready to understand it. Hayworth representation of glucose. So this was the chain structure of glucose. See, focus over here. COH and this oxygen. Do you remember this oxygen? The oxygen which is attached to the fifth carbon. Let me number it. 1, 2, 3, 4, 5 and 6. HOH, HOH, H, HOH. Could you please let me know in the chat section, this is alpha D glucose or beta D glucose? Just let me know, otherwise you won't be able to understand. You won't be able to understand the Hayworth representation if you don't know what is this. This is alpha D glucose or beta D glucose. Just let me know in the chat section, my dear students, what is this? This is alpha D or beta D glucose. I'm waiting for your answer. I'm waiting for your answer, my dear students. If you are able to understand this is alpha D glucose or beta D glucose, then definitely you are going to understand the Hayworth representation. Otherwise, you won't be able to understand this chapter. Just to let me know in the chat section, this is alpha D glucose or beta D glucose. Very good. That's really awesome. This is your alpha D glucose because first carbon OH and third carbon OH are on different side. So this is alpha D. D is for these oxygens are on same side, D positive, experimentally determined, and this is being glucose, glucose, glucose. Now let me draw the Hayworth representation. See, my dear students. This oxygen, do remember this oxygen. This is the most important thing. Just remember this oxygen. I'm talking about this oxygen. This is joining the first carbon as well as the fifth carbon. It is a bridge in between first and fifth carbon. Just focus over here, my dear students, what I'm talking about. This oxygen is acting as the bridge in between first and fifth carbon. So let me say this is your first carbon and this is fifth carbon. What is the difference between first and fifth carbon? Just do let me know and just try to understand what's the difference in between first and fifth carbon. At first carbon, OH is attached and H is there, and this oxygen is also over here. Now my dear student, just remember this third carbon OH. Let me draw 1, 2, 3, 4, 5, and this is your sixth carbon OH, because this is not the part of ring. Now my dear students, see to it, everyone see to it. Third carbon OH is on the top. Remember that always whenever you are going to focus on this structure, remember that this third carbon OH is on the top. If third carbon OH is on left hand side, then rest of other OH are on right hand side. That means if third carbon OH is at the top, third carbon OH is at the top, rest of other hydroxyl group will be there, downward side or upward side. Just do let me know in the chat section. Just do let me know in the chat section if this third carbon OH is going upward side. This was on the left hand side, then rest of other hydroxyl group were on the right hand side. So rest of the hydroxyl group will be on the top hand side or the down side. Just let me know in the chat section. Yes, my dear students, just to let me know in the chat section, the rest of hydroxyl group will come downward side or upward side? Downward side, very good. So H, OH, H, OH, H, OH. So this is same structure. This is the normal form, this is the Fisher projection formula, and this is the Hayworth representation formula. This is your Hayworth representation. If you know this Hayworth representation, if it is very much clear to each and everyone, definitely you are going to kill this chapter. If this structure is clear to each and everyone, just do let me know in the chat section. Yes, this is clear. This is clear. If this is clear, just show the thumbs up. Yes. If this structure is clear to all of you. Once this structure is clear to all of you, just do let me know in the chat section. That's yes, you are able to understand it. I'm waiting for your answer. So this is alpha D glucose. Now if I'm going to draw beta D glucose, where there is going to be difference in beta D glucose, this OH is going to change or the first carbon OH is going to change. Wow, wow, I can see the Josh is really very high. I can see the Josh is really very high, and thanks for your support. Thanks for your support, my dear student. I can see the Josh is really very high. Yes, yes. Once this structure is clear, I promise you, my dear student, carbohydrate chemistry is going to be there. It's going to dissolve in your blood. And there it is going to be in your brain for always, just like a hard disk memory. My dear students, just see, if I want to draw beta D glucose, where I have to change the third carbon OH or the first carbon OH, where I have to make change, first carbon I have to make change, then I will get beta D. Now see, let me show you in the NCERT what NCERT is writing. See over here, This is the NCERT. NCERT is writing alpha D positive glucose. See why it is alpha D. Just to let me know in the chat section why it is being alpha D. See, first carbon OH, first carbon OH, first carbon OH and third carbon OH, they are on opposite side, that's why alpha D glucose. And see, first carbon and third carbon OH are on the same side, they are beta D glucose. Is this clear to all of you? And what's the relation in between these two structures? They are being epimers, they are being anomers, and they are being diasereomers. And overall they are being configurational isomers. Is this clear? I am taking NCERT along with me because each and everything is going to come from NCERT only in your examination. Now see, Hayworth representation, what I have told you. Just try to find out what I have told you. Here first carbon OH and third carbon OH, they are on opposite side. First and third, 1 and 3, first and third carbon OH are on opposite side. What do you call it? Just do let me know in the chat section. 1 and 3 carbon OH are on opposite side. You are going to say they are alpha D glucose. And see over here, first and third carbon OH, they are on the same side. First and third carbon OH are on the same side. You are going to get this is beta D. Beta D glucose. So, now the main question arises, why glucose has formed a ring of hemiacetal with intramolecular cyclization only? Why it is not going to form a ring like intermolecular? See, this is your glucose, this is your glucose, now this is forming ring with this carbon only, and this hydrogen is forming ring with this carbon only. After ring formation also this is remaining one molecule only. So the change in delta S, change in entropy will be 1 minus 1, that's approximately coming out to be 0. And because new bond is formed from the left hand side as well as from the right hand side, both the sides, though delta H will be what? Just to let me know in the chat section, delta H will be exothermic reaction or endothermic reaction, because once the bond is formed, this is going to be exothermic reaction. That means change in entropy is coming out approximately to be 0. Why I am writing approximately to be 0? Because the number of vibrational energy and rotational number of things, energies are there, they may get changed. Now delta H is negative, this means this reaction is being exothermic, new bond is formed. Once the new bond is formed, so my dear students, delta G, that's Gibbs-Helmholtz equation, that is delta H minus T delta S, that is going to be negative. So who is deciding this going to be negative? Because delta H is negative. Now if two molecules are combining, then definitely change in entropy, because 2 molecules will become 1, 100 molecules will become 1, that means the entropy is getting decreased. So always remember that whenever by intramolecular cyclization, if ring is formed of 5, 6 or 7 membered, remember that ring strain should not be there. Either ring should be of 6 membered or 5 membered or 7 membered, then always give preference to intramolecular cyclization. If the ring is smaller than 5 membered, then intramolecular. If it is more than 7 membered, intramolecular. Otherwise always give preference to intramolecular cyclization. Now my dear students, 2 glucose molecules, alpha D glucose molecules. Oh, so here is one question. So everyone, are you ready for the question? Just do let me know in the chat section. Are you ready? Are you ready? Are you ready, my dear students? So here is one question. Just try to understand. So question is, which of the following statement is not true about glucose? Focus over here, not true, because if you forget this thing, if you're not able to, not true, just try to focus on not true. I'm waiting for your answer. It is an aldohexose, contains 5 hydroxyl groups. It's a reducing sugar. It is an aldopentose. Wow, your answer is absolutely correct. That's really awesome. This is wrong because it is aldohexose, not aldopentose. So you got 4 marks. Are you feeling happy? Are you feeling happy? Are you feeling happy? Just show me the thumbs up if you are feeling happy. Now, this is your maltose. Maltose. Glucose was thinking that everyone is going to consume me. Instant source of energy. Even the patients, they are absorbing me. Let's make our strength. So they have combined 2 molecules of alpha D glucose combined together, and the more clear structure should be like this, because if it is given in NCERT, their bent is there, so that is indicating bond line rotation, 1 carbon is there. So see, OH, OH, this alpha D glucose first carbon is involved, and that alpha D glucose 4th carbon is involved. Are you getting my point? Just think, this is the mouth and this is the tail. 4th carbon is the tail of alpha D glucose and first carbon is the mouth of alpha D glucose. What I am saying, are you able to understand? Are you able to understand? This first carbon is the mouth and the 4th carbon is the tail. If you are able to understand, just do let me know in the chat section. Otherwise, I will draw new structure. Let me draw new structure. See to it. Everyone see to it. HOH, HOH, and the 3rd carbon OH should go upward side. HOH, HCH2OH. This is 1 alpha D glucose. And what I'm saying, my dear student, this is the mouth. Why I'm saying this is mouth? If you are going to eat popcorn, we have to eat popcorn like this. And once the mouth is closed, popcorn will not be inside the mouth. So this is right now closed chain. But do remember, the first carbon was anomeric carbon. Do you remember in brain? First carbon is being anomeric carbon. This carbon is being anomeric carbon. This anomeric carbon was permanently closed, or it was moving like it was in equilibrium with open chain and closed chain. Just to let me know in the chat section. Yeah, my dear student, this what's the name? Cherukuri Ganeshwar. Wow, really I like your comment. Cherukuri Ganeshwar ji. Yes, this is alpha D glucose. Very good analogy. Alpha D glucose, this is the mouth and this was opening and closing. Once the alpha D glucose was in the water, the aqueous solution was in between open chain and closed chain, because this oxygen, the 5th carbon oxygen, was not the permanent of first carbon. That oxygen was permanently attached with the 5th carbon, but with the first carbon it was forming the bond and it was deforming the bond. Forming bond, deforming bond. Once it was forming the bond, we are saying it is open closed chain structure, and once the bond was breaking, we were saying this is open chain structure. Are you getting my point? Are you getting my point? My dear students, are you getting my point? So this was not the permanent bond. This bond was opening and breaking, closing and forming and deforming. So another alpha D glucose, the second molecule. See to it, my dear students. HOH, and the 3rd carbon's OH on the upside. HOH, HCH2OH. Now my dear students, now see to it. This is your first carbon and this is your fourth carbon. This is the tail. This fourth carbon is being tail. Now they are forming the water. They are forming the water. That means the water has been evolved from the first and fourth carbon. First and fourth carbon is involved in the bond formation, and this bond is forming. That means this oxygen will be there, and this is known as glycosidic linkage. Glycosidic linkage. Are you getting my point? This is known as glycosidic linkage. But do remember, its mouth is free. It is not involved in the bond formation. This mouth is free. That means here the carbonyl group is free. Which group is free? Carbonyl group. This carbonyl group is involved in the bond formation, but here the carbonyl group is free. Are you able to understand what I am talking about? This carbonyl group is free. Are you getting my point? What I am talking about? This carbonyl group is free. That means if you are adding tolerance reagent, if you are adding Phelan solution, hey, my dear students, are you getting my point? That if I am talking about this carbonyl group is free, that means this can reduce. Yes, this can react with tolerance reagent. This can react with Phelan solution. So it is a reducing sugar. This is going to be reducing sugar. This is known as reducing sugar. Why it is going to call it reducing sugar? Because it can give tolerance test, positive tolerance test, positive Phelan test, positive Benedict's test. That's why maltose is known as reducing sugar. That's why maltose is known as reducing sugar, and all reducing sugars are going to show mutarotation. So till now, if everything is clear, now we are going towards lactose. So how many of you find difficulty in remembering the structure of lactose? Just do let me know in the chat section if you are going to find difficulty in lactose. My dear student, I have told you what was lactose and how was the structure of lactose. Let me draw lactose. As I have told you, 1, 2, 3, 4. CH2OH, CH double bond O, lactose. So fourth carbon there was difference. On the fourth carbon there was difference. So this is the fourth carbon. Here is the difference. As we know the structure of glucose, so how galactose is different from glucose? Only on the fourth carbon. This is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. So this is galactose. See to it. Third carbon was moving upside, so fourth carbon is also moving upside. Can you understand? Yes or no? Just let me know. Yes or no, this is galactose. Can you understand why it is D-galactose? Because the last and second last carbon are on the same side. That's why D and D-galactose. Why it is D-galactose? Just let me know. Yes, my dear students, are you able to understand? After your trick, it becomes easy. Thank you for your appreciation. Now this is galactose and this is glucose. So galactose first carbon I would like to say its mouth is involved, and its tail is involved. So could you please help me out just to understand? This is galactose and that is glucose. Beta D glucose and beta D galactose. Lactose is made up of beta D glucose and beta D galactose. Could you please help me out that anyone's mouth is free? Anyone's mouth is free? Yes, this mouth is free. Mouth is free. And once the mouth is free, that means this is also going to be reducing sugar. Reducing sugar, and reducing sugar will show mutarotation, my dear students. It will show mutarotation. Yes, mutarotation, and it will give positive tolerance and positive Phelan test. Positive tolerance test, positive Phalenx test. So it is a reducing sugar. Till now, if everything is clear, just do let me know in the chat section that you are able to understand. Yes? Show thumbs up in the chat section. Yes, I am waiting for your answer. If everything is clear to you, you are able to understand what is lactose, what is reducing sugar, what is tolerance test, whether it is going to show positive tolerance test or positive Phalenx test. Just do let me know. Now, polysaccharides. Till now we have seen two molecules of alpha D glucose or beta D glucose or galactose, they have combined to form disaccharide. Monosaccharides are sweet in taste, disaccharides are sweet in taste, oligosaccharides are sweet in taste. That means if any entity is made up of 3 to 10 saccharide units, up to 10 saccharide units, they are sweet in taste. More than that, they are known as polysaccharide. So we are going to deal with polysaccharide. So if I say number of alpha D glucose, they are combining together, means if I say 200 to 1000 alpha D glucose are combining together, they will form starch amylose. Starch amylose and starch amylopectin, they are polysaccharides. They are polysaccharide. Amylose and amylopectin, they are polysaccharide. This amylose, it made up of 1,4-glycosidic linkage of 1,4-glycosidic linkage of alpha D glucose. And if I say amylopectin, if I talk about amylopectin, this is made up of 1,4 as well as 1,6 linkage of alpha D glucose. Yes, so they are polysaccharides. They are polysaccharides. And their first carbon, if I talk about number of polysaccharides, if their first carbon is involved in bond formation, they are not going to show tolerance test and Phalenx test. So they are non-reducing. Are you getting my point? They are non-reducing. Is this point clear to all of you? Are you getting my point? So number of alpha D glucose, they are combining together, they are going to form, say, starch amylose. This glucose, first carbon is involved and fourth carbon is involved. First carbon is involved, fourth carbon is involved. First carbon is involved, fourth carbon. So this lengthy chain of alpha D glucose, all the first carbon, that means anomeric carbon, each and every anomeric carbon is involved in the bond formation. Are you getting my point? Everyone getting my point? That means 200 to 1000 alpha D glucose units. What I am talking about, 200 to 1000 alpha D glucose units, they are forming a bond. That means none of the first carbon is free. Are you getting my point? Everyone, is this clear to all of you that no first carbon is free to react with tolerance or Phalenx solution? That's why it is a reducing or non-reducing. So definitely non-reducing compounds. So they will show negative tolerance and Phalenx test. I hope this much is very much clear to all of you, that because the first carbon, that is being the anomeric carbon, it is not able to react with tolerance reagent, that is ammonical silver nitrate solution and Phalenx solution. So these are non-reducing. Yes. This is very much clear to all of you. So if anyone is asking starch amylose is made up of, what should be your answer? If anyone is asking starch amylose is made up of, starch amylose is made up of, just do let me know in the chat section what's the answer. Starch amylose is made up of. Starch amylose is made up of. What's your answer? Alpha D glucose. Alpha D glucose. Alpha D glucose. Second question. It is disaccharide, monosaccharide or polysaccharide? So the answer is it's polysaccharide. Now the third point is, it is going to react with tolerance reagent or not? Yes. Another question is whether it is going to react with tolerance reagent or Fehling solution or not. Will not react. Answer is will not react. Will not react with tolerance reagent and Fehling solution. Fehling solution. This point is very much clear to all of you. Now, amylopectin. I am going towards amylopectin. So, each and everything is based on glucose structure only. Are you able to understand that everything is it's based on structure of glucose only. So, the structure of glucose is very, very important. Structure of glucose is really very, very important. Now, just try to find out what I am showing you. One layer of alpha D glucose, 1,4-glycosidic linkage and one layer of glycosidic linkage. Let me write it down so that, suppose if I say this layer of alpha D glucose, suppose if I say this is alpha D glucose, if I say this is alpha D glucose, this is also alpha D glucose. Now, they are joined together like this. They are joined together like this. This is the fourth carbon and this is the first carbon. We'll say 1,4-glycosidic linkage. 1,4-glycosidic linkage. Is it clear? This was in the starch amylose, but amylopectin is a little bit more complex structure. See how? See to it how? I am drawing one more alpha D glucose, like a chain or polymer, you can say alpha D glucose, and they are also joined together, its first carbon, its fourth carbon, 1,4-glycosidic linkage. Now, what's the difference in between starch amylose and amylopectin? In starch amylose, there was a linear chain of 1,4-glycosidic linkage. Are you getting my point? Are you getting everyone? In starch amylose, there was a linear chain of 1,4-glycosidic linkage, but in starch amylopectin, there is one more linkage. Along with 1,4 linkage, in this chain and in this chain, in between two chains, there is one more linkage, and that linkage is known as 1,4-glyco, along with 1,4-1,6, its first carbon and its sixth carbon, 1,6-glycosidic linkage. Are you getting my point? Along with 1,4-glycosidic linkage, there is 1,6-glycosidic linkage. Just try to find out, just focus over here. 1,6-glycosidic linkage means 1,4 plus 1,6-glycosidic linkage, and that's why starch amylopectin is water insoluble. Starch amylopectin is water insoluble. Why? Somebody is asking why it is water insoluble. What's the reason? What's the reason why it is water insoluble? Starch amylose is water soluble because this was having, starch amylose was having only 1,4-glycosidic linkage. But in amylopectin, amylopectin along with 1,4-glycosidic linkage, there is 1,6-glycosidic linkage also, and that's why this structure is more complex, more number of branches, more number of bonding, and that's why it is what? It is water insoluble. And if I talk about three structures, one is being starch amylose. Only 1,4-glycosidic linkage. 1,4-glycosidic linkage, right? If I talk about starch amylopectin, along with 1,4, there is 1,6-glycosidic linkage also. Now, the third structure, if I talk about the third structure, that is being glycogen. Have you heard this name? Anyone, just let me know, have you heard this name? Glycogen. I'm saying starch amylose, we know very well. Starch amylopectin, I have told you. If I talk about glycogen, just do let me know in the chat section, do you know anything about glycogen? So glycogen is known as that animal starch, the carbohydrate. Your bio students, you know very well. That carbohydrates are stored in the human body in the form of animal starch. Yes, really, you know everything. So this is even more complex structure, even more complex structure. And this is also made up of alpha D glucose only. So three compounds you have got, these three all are polymers. And what is the monomeric unit of this? Definitely the monomer is alpha D glucose. Alpha D glucose is the monomer of all these three, whether I talk about starch amylose, if I talk about amylopectin or glycogen. Just do let me know in the NCERT. So here is the question. Oh, great. The difference between amylose and amylopectin is, let me see whether you are able to get full marks or not. Yes. The difference between amylose and amylopectin is 1, 2, 3, 4. 4 options are given over here. Just try to find out what's the correct answer. C. Nilofer is writing C. Christian Rajant is writing alpha D glucose. C. Puriji Pani Puri. Wow, what a name, Pani Puri. Jyothi Valaru Pani Puri, Falaha, Piyush, everyone is writing 1 A. So let me see. Oh, great. Oh, you got the correct answer. Just give thumbs up to yourself. Just give hearts to yourself. Just make the chat section colorful, because really it's the happiest moment that you are able to solve the question of biomolecule, because biomolecule is really the awesome chapter. Just give salute to yourself. Just show thumbs up for yourself only. It's your channel only, my dear friends. Yes, wow, you got the correct answer. Salvates. Oh, polysaccharide, the cellulose is the dawn. Cellulose is the dawn. Why it is the dawn? Because human beings can't digest. So cellulose is the dawn. Cellulose is really the dawn. Cellulose is the dawn. Why it is dawn? Human beings can't digest. Human beings can't digest cellulose, can't digest cellulose. So being bio students, you know very well, why human beings can't digest cellulose, because to digest cellulose, one thing is required, vermiform appendix, the bacteria is required, and this cellulose can be digested only by ruminant animals. These ruminant animals have 4 legs. Now, thank you, Kathivaran Sekharji, thank you, it means a lot. It means a lot, really. It's a complex, and remember that this huge structure, if it is going to come in the paper, people will understand, students will understand, oh my God, I won't be able to do it, because such a large structure, how the question can be framed. They will make this structure. The examiner will make this structure, and the examiner will ask, oh, just find out, this is sucrose, this is starch amylose, this is amylopectin, or this is glycogen. So what you will say? Just try to focus, only one polysaccharide in your syllabus is there, which is made up of beta D glucose. This is made up of beta D glucose. Let me tell you, this is the only structure which is made up of beta D glucose. How to find out it is beta D glucose? How to find out it is beta D glucose? Is there anyone who is going to tell me how to find out? I have told you in the starting only what was the trick to find out alpha D glucose and what was the trick to find out beta D glucose. What I have told you in the starting, how to find out beta D glucose. The third carbon OH was always on the top, and first carbon OH must be on the top. The first and third carbon OH, first and third carbon OH, that is hydroxyl group, must lie same side, on same side. Am I right? Just do let me know in the chat. Am I right? Just do let me know in the chat, because the structure is nothing is tough. If you do remember just one thing, my trick, if first and third carbon OH, they are on same side, then we will say it is beta D glucose. Now try to understand, try to focus over here. This was your first carbon, second carbon, third carbon OH and O. Are they on same side? First carbon O to third carbon O, are they on same side? So definitely this is cellulose, because it is made up of beta D, beta link. See, beta link is written over here. If you are getting this point, if you are able to understand, if it has become easy, just show your thumbs up, keep yes. If it is clear, if there is no problem, you are not feeling any problem, if everything, each and everything is clear to you, just do let me know in the chat section. Now it has become easy. Just show the thumbs up or some signal, green signal in the chat section. If it is perfectly clear, crystal clear, just do let me know. Yes. How's the Josh? Now are you able to understand this thing? Because always student is searching here and there how to do this chapter. I find it difficult. So everyone is able to understand. Just to let me know in the chat section. Wow, your satisfaction. I can see your satisfaction. I can see you that yes, it's crystal clear. So polysaccharide glycogen, what I have told you, glycogen, what I have told you about glycogen, what I have told you about glycogen. Glycogen was made up of alpha D glucose. This already I have told you, alpha D glucose, even more branched. This already I have told you, also known as human starch. If the question is asked in your exam, this glycogen is reducing or non-reducing? This glycogen is reducing or non-reducing? Just let me know in the chat section if you are able to understand this glycogen is reducing or non-reducing. I am waiting for your answer. Is this reducing or non-reducing? What will you say in the exam? This glycogen is reducing or non-reducing? Yes, yes, yes. I am coming to fructose. Don't worry. I will kill that fructose also. I will make you understand that fructose also non-reducing. Yes, this is non-reducing. Now if the examiner is asking whether it give positive tolerance test or negative tolerance test, positive tolerance test or negative tolerance test, because examiner will definitely ask you, will show positive tolerance test or negative tolerance test. I am waiting for your answer. Polymer, yes, this is showing positive or negative. So will not show, will not show, will not give tolerance test and phalanx test, tolerance and phalanx test. So let's move ahead. Preparation of glucose, this to know very well, because sucrose on hydrolysis gives glucose and fructose, and starch or cellulose on hydrolysis will give glucose. Because these are being polymers, this is your disaccharide, this is your disaccharide, these are giving monosaccharides, monosaccharide, this is your polysaccharide, this will give you monomer glucose. Now heating with HI. If you are not able to understand the reactions of glucose, just do let me know in the chat section, then I will write these reactions individually. Okay, let me show you how these reactions are going to proceed. Glucose, as I have told you, glucose was like this. Glucose was like this. 1, 2, 3, 4. CH double bond O, CHOH, 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 CH2OH. This was your glucose. First carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. If you are adding HI, just remember that what's the function of HI. Yeah, I will give you memory chart for polymers. Yeah, I have seen in the chat section. Don't worry, I will give you memory chart for polymer. I will make you understand with perfection about the polymer, about the monomers of the polymer. Don't worry, I'm here, so no need to worry, right? Okay. So this HI, what this HI, role of HI, let me tell you role of HI. If we have RCHO and if you are heating with HI plus heat, it will convert RCHO to RCH3. One thing, if you are having RCHOH and if you are heating with HI, it will convert it into R2CH2. If you are having 1 degree alcohol, RCH2OH, when it reacts with HI and heat, you will get RCH3. Are you able to understand? 3 reactions I have written, first, second and third. That aldehyde will convert into hydrocarbon, secondary alcohol will convert into hydrocarbon, and primary alcohol will also convert into hydrocarbon. Are you able to understand these 3 reactions? Just to let me know. Just to let me know. Your HSP is over here, so no need to worry, my dear student. Just let me know in the chat section. This aldehyde will convert into alkane, this secondary alcohol will convert into hydrocarbon, this primary alcohol is also going to convert into this. So see, this glucose is having aldehyde, this will convert into hydrocarbon. These 4 secondary alcohols they will convert into hydrocarbon, and this is primary alcohol. This will also convert into what? Hydrocarbon. So how many carbons are there? 6 carbons, C6, H12, O6. So all these 6 carbons will form an hexane. Now is it clear? If you are able to understand, if everyone is able to, Sampath-ji, yes, I am happy. Sampath-ji, just do let me know in the chat section. Everyone, my dear students, just let me know in the chat section if this point is very much clear to all of you. I hope this is very much clear to all of you. So see, reaction with hydroxylamine, how the reaction takes place with hydroxylamine, let me tell you. If we are having any RCHO, RCH double bond O, and if it is reacting with hydroxylamine NH2OH, so what you will get? Just find out. We have to eliminate out water. Just remove water. What will you get? After removal of water, you will get RCH double bond NOH, hydroxylamine plus water. Just to let me know, are you able to understand this reaction? Water will eliminate out. So see, glucose, this is your glucose, and it has been reacting with hydroxylamine, so you got oxime of glucose. So its name is glucoxime, or we can say oxime of glucose. And the second reaction, this is reaction with hydrogen cyanide. How this reaction? This reaction you have studied in nucleophilic addition reaction. So this will react. See how it is going to react. RCHO, the second reaction, I am talking about second reaction, RCH double bond O plus hydrogen cyanide. You can see to it, everyone, just focus over here. Hydrogen cyanide. See, this is delta positive, this is being delta negative, this is being delta positive, and this is being delta negative. How the reaction will take place? This positive part will come and join over here, and the negative part will come and join over here. You will get cyanohydrin like this, RCHOH CN, cyanohydrin. You will get this compound. So this is your glucose, and glucose is doing reaction with hydrogen cyanide. So you got glucose cyanohydrin. The name of this compound is glucose cyanohydrin. So let's move ahead. This is your question. Just try to find out. This question is of 2014 All India Medical Examination 2014. I'm waiting for your response. Just do let me know in the chat section if you are able to understand. Question is D positive glucose. D positive means dextrose, dextrorotatory. D positive glucose reacts with hydroxylamine and yields an oxime. The structure of oxime would be. Yes, everyone. What's your answer? Yes, I am waiting for your answer. D. Everyone is saying D. Let me understand. CH double bond, HOH, third carbon. Oh, you are talking about D. Third carbon OH is on left hand side. It's okay. Rest of, yes, I think you are giving the correct answer. That's really awesome. See, everyone's answer is correct. If your answer is correct, just do let me know the thumbs up in the chat section. That's really awesome. Now, formation of gluconic acid. See how this reaction is going to proceed. Everyone just try to find out. If I am provided with RCHO, and if I am reacting with bromine water, Br2 water, this RCHO will convert into RCOOH. That means aldehydic part is getting converted to acid, carboxylic acid. This you have studied in aldehyde and ketone chapter, carboxylic acid. So glucose is having one CHO group. On reaction with bromine water, you will get gluconic acid. Gluconic acid. This bromine water is mild oxidizing agent. Mild oxidizing agent. Mild oxidizing agent. Mild oxidizing agent. So I think this is very much clear. But remember that fructose does not react with bromine water. That is the most important thing. Let me show you. If the question is coming in your exam, question is, how will you distinguish? How will you distinguish glucose and fructose? This is the most important question of your exam. Glucose and fructose. How will you distinguish in between glucose and fructose? So what's your answer? Is there anyone? How will you distinguish in between glucose and fructose? Is there anyone who can give the answer? Is there anyone? So the answer is definitely Br2 water. Br2 water. Because glucose on reaction with Br2 water gives gluconic acid. Whereas fructose is not going to react. Fructose is not going to react with Br2 water. No reaction. What's the reason? Why no reaction? What's the reason? Because fructose is a ketone. Fructose is a ketone, and ketone does not react with mild oxidizing agent. Ketones are more stable. Ketones are being more stable. So they will not react with bromine water. Now people will understand. You have to understand, we cannot use tolerance reagent and Fehling solution. Yes, it is a ketohexose. This ketohexose is not going to react with bromine water because bromine water is mild oxidizing agent, and do remember fructose reacts with tolerance reagent and Fehling solution. Now you will say tolerance and Fehling reagent are also mild. Yes, they are mild agents. Then why fructose is going to react? See the question. Try to understand what's the question. Question is, brilliant question. Even fructose is ketohexose. But then also it reacts with tolerance reagent and Fehling solution. Now this is the very important question. Fructose is a ketohexose, but then also it is going to react with tolerance reagent and Fehling solution. Although we know that tolerance reagent and Fehling solution does not react with ketone, it is written very clearly in the NCERT. It is written very clearly in the NCERT. If I talk about NCERT, NCERT says tolerance reagent, Fehling solution does not react. Don't react with ketones. Am I right or not? Am I right or not? Just do let me know in the chat section what I am writing. This is already written in your NCERT. This point to be noted, my lord. This is the most important note. Keep in your brain that NCERT says tolerance reagent and Fehling solution does not. They don't react with ketones. But the question arises, my dear students, how does this fructose is going to react with tollens and phalanx? This is the most important question. Now, I am going to tell you the basic and the mechanism behind it. No, this is not the reason, Sandhya ji, this is not the reason. Let me tell you in detail. I am going to tell you in detail. See everyone, just see to it. Everyone just see to it. This is your fructose. This is your fructose. CH2OH, C double bond O, CHOH third carbon, fourth carbon, fifth carbon and sixth carbon, right? Can you understand? This is your fructose. Everyone, now see to it. If I add tollens reagent to it, if I am adding tollens reagent to it, what is tollens reagent? Ammonical silver nitrate AgNO3 plus ammonium hydroxide. So this is the important point, that it is giving basic medium, and this basic medium definitely do the tautomerization. How the tautomerization will take place? See to it, tautomerization. 1, 2, 3. This hydrogen will come from 1 to 3. This oxygen and double bond, yes, 1, 2, 3, not over here. This hydrogen will come at this carbon and double bond will switch over here. See, 1, 2, 3 and double bond. This hydrogen will come to the third carbon and double bond will switch over here. What you are, let me write down this as R. Let me take this as R. So what you are going to get? CHOH double bond COH and the R. This part I have taken, I have considered it to be R just to save our time. So see, this is double bond in, and these are two OH diol, in diol. This is the intermediate. This is the intermediate in diol. Now, once again the tautomerization will take place. Once again tautomerization will take place. See to it. Once again tautomerization will take place. Now, 1, 2, 3. Just see to it. 1, 2, 3. This hydrogen will come at this carbon and double bond will move to 1, 2, in between 1, 2. This double bond will go in between 1, 2 and this hydrogen from first carbon to come to third carbon, and this is being sp2 hybridized. That means on sp2 hybridized, it will come from the right hand side as well as it will come from the left hand side. It is going to form two structures. See, what are those two structures? CH double bond O, CHOHR plus CH double bond O, CHOHR. Now, my dear student, one is being glucose, this is being glucose, and that is being mannose. So, ultimately fructose has not given the tolerance test. That is not the fructose that has given tolerance test. It is actually glucose and mannose. They have given the tolerance test. Actually, NCERT was absolutely correct that aldehydes gives tolerance test. Now further we will say all alpha hydroxy ketones, whatever the alpha hydroxy ketones we are having, alpha hydroxy ketones, all alpha hydroxy ketones of this world will give tolerance test. Not only this fructose is going to give tolerance test of this world, whatever the alpha hydroxy ketones are there, they are going to give tolerance test, and this rearrangement is known as Lowry-D Brown Van Ekenstein rearrangement. What it is called as? This is known as Lowry, this rearrangement is known as Lowry-de Brown, when a Kinston rearrangement. A little bit tough name, Lowry-de Brown when a Kinston rearrangement. No need to learn this name, but yes, do remember your brain. This is not the ketone who has given the tolerance test or Falling's test. This is a redox reaction which is given by aldehyde. I think this point is very much clear to all of you. This point is very much clear to all of you. Let's move ahead. Acetylation. Acetylation reaction, how does it proceed? Acetylation reaction, see to it. If I am having CHOH, that is primary alcohol or secondary alcohol, whatever the alcohol, primary alcohol or it can be your secondary alcohol. So whenever it is going to react with acetyl chloride, see acetic anhydride, CH3, C double bond O, O, C double bond O, CH3. This is your acetic anhydride. How the reaction is going to take place? This is delta negative and this is being delta positive. So you can see to it what is going to remove from here. The bond is going to break and this OH will go along with CH3, C positive. See, this will remove. So what you will get? You will get R, CH, O, let me change the color, O, CO, CH3. So this acetyl group will form a bond. So this glucose is having how many OH bond? Could you please let me know? This glucose is having how many OH? 5 hydroxyl groups. So how many acetyl groups you will get? You will get 5. That means penta-acetyl glucose. You will get penta-acetyl glucose. Why we have got? Because it is having 5 hydroxyl groups. Glucose is having 5 hydroxyl groups. So we will get penta-acetyl glucose. Are you able to understand? Now another question, oxidation with nitric acid. This is the most important point which we have to keep it under that brain, because when glucose was reacting with bromine water was mild oxidizing agent. Only one CHO bond got changed, or the group got changed to COH group. Here this CHO and this CH2OH both will get oxidized, both will convert into COOH group. This will change into COH, this will also turn into COH. So you can see at two places you will get the change, and this is known as saccharic acid. Another name of saccharic acid is glucaric acid. My dear student, don't get confused, glucaric acid and gluconic acid. One was conic acid, one was gluconic acid. See, this is gluconic acid, only one COH. This we have got from glucose. When glucose was reacting with bromine water, we got gluconic acid. Either I am having glucose or I am having gluconic acid, both are going to get saccharic acid. Saccharic acid's another name is glucaric acid. Is this point clear to all of you? Now let's move ahead. Fructose. So are you ready for the fructose, everyone? Just do let me know. Just show the thumbs up in the chat section. Just show the thumbs up in the chat section, everyone. If you are ready for fructose, see to it. Fructose. Now, first of all, I am going to draw fructose on the plain slide. Plain slide, see. CH2OH C double bond O, CHOH, CHOH, CHOH and CH2OH. Just check it out. How many carbons have drawn? Just check it out. 1, 2, 3, 4, 5, 6. On the third carbon, OH is on the left hand side, rest are on the right hand side. Can you see? Its carbonyl group is in the second carbon, and this fifth oxygen is going to form a bond with this carbon from both the side, from the right hand side as well as from the left hand side. This is going to form a bond from both the side. Can you understand, dear students? Now, how many atoms ring you are going to get? 1, 2, 3, 4, 5. That means this time you are going to get structure like this. Structure like this. Could you please let me know what it is called? Could you please let me know what it is called as? It is called as furan. Furan. Furan is 5-membered ring. 5-membered ring means 4 carbon plus 1 oxygen. 4 carbon plus 1 oxygen. That's why fructose furanose structure is more stable. Furanose is more dominating structure. Are you getting my point? This is going to form a ring like this. If this thing is clear to in your brain, you can do anything. You can understand any structure if this is clear to all of you. If this is very much clear to you, you can understand each and everything. This is going to form furanose ring structure, and once again I am going to draw its ring structure along with its Hayworth representation. If you are able to understand that, you can get each and everything. Are you ready? How is the Josh? I think your Josh is high or not. Just do let me know in the chat section, how is the Josh? Are you going to understand the ring structure, furanose ring structure of fructose? Just do let me know in the chat section. So see to it everyone. CH to OH, C double bond O, CHOH, 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 CH2OH. Now this fifth carbon oxygen, this is going to form on this carbon. This is sp2 hybridized. It will go from this side and it is going to form a bond from this side. So what will you get? You will get COH, CH2OH. This is the first carbon, this is second carbon, this is third carbon, this is fourth carbon, and this is your fifth carbon, and fifth carbon's oxygen I will draw with red color so that you are able to understand that this is the bond. And let me come back to the white color. This is CH2OH. Now you have to find out, this is second carbon OH and this is third carbon OH. They are on opposite side. Second and third carbon OH hydroxyl groups, they are on opposite side. Once they are on opposite side, what will you call it? First let me show you that last and second last carbon OH are on the same side. So we'll say yes, D fructose, and I know very much with the fantastic awesome clarity that these are on opposite side. We'll say alpha. Word I will use alpha D fructose. Is this clear to all of you? Alpha D fructose. If second and third carbon OH are on same side, what do you call it? If they are on same side, what do you call it? You will call it beta D fructose, beta D fructose. This is the only difference, and this you have to understand what is alpha D fructose and what is beta D fructose. Is this clear to all of you? If this is the point which is very much clear to all of you, dear students, then you can understand anything. That is the difference. Yeah, I will take separate class for polymers because too much time is not there. Just to like and subscribe the channel and just let me know how is the Josh. How is the Josh? I'm telling you each and everything on the plain slide so that it is going to get very much clear. So time is not left that much so that I can tell you, I can let you know about the polymers. I will take separate class of polymer, but whatever we are going to study, that thing should be very much clear in your brain so that you will get full marks, full confidence. These are the very important point. This is not going to help you in chemistry only. This is going to help you in a biomolecules with the bio also. Now, see, this is fructose. Can you see fructose? First carbon. This is the carbonyl group, and carbonyl group is on the second carbon. So, if anyone is asking which is the anomeric carbon in the ring chain structure, notes I will give you on the Telegram channel. You will get the notes. Definitely, I will let you know about the second part of reaction mechanism also. Definitely, whatever you are asking, I will fulfill those things. Second part of reaction mechanism, name reactions, you will be getting, my dear students. And just now focus on what I am telling you. You will get notes on Telegram channel. Definitely you will get. See, here is the structure furan. Can you see? Can you focus over here? This is the second carbon, and second carbon OH is over here. What do you call it? Oh, this is not, we have not to focus over here. See to it. This is second carbon OH and this is second carbon OH. They are on opposite side. Opposite side, what do you call it? Opposite side, you will call it alpha, and they are on same side, second and third carbon, you will say it is beta. Now, see the structure of Hayworth representation. This is the most important thing. This is really the most important thing. People get confused in this structure only. Just try to find out how to draw this structure, because this structure is really important. See how to draw it. See, everyone try to draw it along with me. Just make a boat. Let me make a boat. Everyone just see to it. I am making a boat. Boat is like this. This is the boat. Can you see? And this boat must be attached with this oxygen. This oxygen which is making a bridge. This oxygen was making a bridge in between which carbons? Could you please help me? This oxygen was making bridge in between which carbons? The first and fifth carbon or the second and fifth carbon? Could you please help me? If you are able to understand this point, then you can kill this chapter. This oxygen was making a bridge in between second carbon and the fifth carbon. Am I right? Just do let me know in the chat section. Am I right? And we have to remember one more point. That the most important point. Second carbon OH was on the top. When second carbon's OH was on the top, rest of OH will lie on opposite side. They have to lie on opposite side. Are you getting my point? They have to lie on opposite side. If we are interested in alpha D fructose, I am going to draw structure for alpha D fructose. Now at this place I have to place CH2OH. At this place I have to place CH2OH because this was not the part of the ring, and H. Is this clear to all of you? If you are able to understand this structure, you can do anything. if you are able to understand this structure, you can understand any compound, any structure. Just let me show you alpha D fructose. Is it matching with this? Just try to find out. The third carbon OH. The third carbon OH is on the top. Rest of OH are lying downward side. This CH2H, this CH2H. See, both are CH2H. This CH2H, this CH2H. The third carbon OH is lying at the top. Now, just see to it. Now, if I am going to make beta D fructose, where the change should be done? If you want to understand the beta D fructose, then the change will be at third carbon or the first carbon? First carbon, because second and third, they will lie on same side. They will lie on same side, they will lie on same side. That's the point. Now see, if I am talking about sucrose, you can understand sucrose is made up of, everyone knows that sucrose is made up of 1 mole of alpha D glucose and 1 mole of beta D fructose. See, alpha D glucose and beta D fructose. So remember that the most important point, if we talk about sucrose, sucrose is actually dextrorotatory. Solid sucrose. I am talking about solid sucrose. Solid sucrose, you can say sucrose, or you can talk about cane sugar, whatever you want to say, you can say. When you are adding it to the water, this sucrose is disaccharide. Sucrose is disaccharide. Definitely, disaccharide will break into monosaccharides. So when you are adding to water, it will make 1 mole of alpha D glucose and 1 mole of beta D fructose. So could you please help me? Could you please help me understanding that here I have added positive sign and for what I have added negative sign? Could you please help me? In case of glucose, I have added positive sign. In case of fructose, I am adding negative sign. So definitely the answer lies that glucose is experimentally found to be dextrorotatory and fructose is levorotatory. Is this point clear to you? Glucose in nature is found to be metabolically active form is dextrorotative. Glucose metabolically active form is dextrorotative and fructose metabolically active form is levorotatory. So this is giving 1 mole of glucose and 1 mole of fructose. So glucose dextrorotatory will rotate the compound. If we talk about spectrophotometer or polarimeter, by which the optical rotation is measured, if I add this sucrose in the solution and if I am going to measure the rotation, the glucose will rotate the plane polarized light in the clockwise direction, whereas fructose is going to rotate the plane polarized light in the anti-clockwise direction. So 1 mole of glucose is rotating the light in the clockwise direction and another mole of fructose is rotating the light in the anti-clockwise direction. But remember that the magnitude of optical rotation of fructose is more. Magnitude of optical rotation of fructose is more. The magnitude of optical rotation of fructose is more, so overall the solution will look like dextrorotatory or levorotatory. So overall solution will look like, so what I am saying, if you are adding sucrose, which is being dextrorotatory to the water, if you are adding this sucrose in the water and you are passing the light, plane polarized light through it, if you are passing the plane polarized light through it, definitely you will find with the help of spectrophotometer, it will be moving in the anti-clockwise direction because the optical rotation of fructose is more, and this is known as inversion of cane sugar. This is known as inversion of cane sugar. Okay, I think this point is very much clear to you. Now, two reactions are not given in your NCERT. I am going to let you know those two reactions which are not given in NCERT. Stay tuned for those two reactions which are very important for your examination, NEET examination, but missing in your NCERT. Just show me the Josh. Do like and subscribe. I want to see the likes getting increased. Then I am going to show you those two reactions, and then I am going to complete this session. I will complete this session with those two reactions. Just do let me know. Just do let me know. Yes, are you ready? How is the Josh? Everyone just let me know how is the Josh. Then only I am going to tell you about those two reactions. They are very important reaction. Very important for your NEET examination, but not given in NCERT. I want to see your Josh. So, see those two reactions. The most important reactions I am going to tell you. Osazone formation. Osazone formation. Osazone is yellow crystalline solid. Yellow crystalline solid. So, this is your glucose. This is your glucose. Now, this glucose on reaction with 3 moles of phenylhydrazine, this glucose on reaction with 3 moles of phenylhydrazine how many moles? 3 moles. It will form CH double bond, C double bond, CHOH whole thrice, CH2OH and NNH C6H5 NNH C6H5. This is your yellow crystalline. How many moles are involved? 3 moles are involved. What are the side products? Side products are water. Side products are aniline C6H5 NH2 and side product is ammonia. And this compound is formed by fructose, mannose as well as glucose. All three compounds form the same compound, whether it is fructose, whether it is mannose, whether it is glucose. All three, they are going to form the same osazone. In case of glucose, I will say glucosazone. In case of fructose, I will use to say fructosazone. In case of mannose, I will say mannosazone. Now, how many of you want to understand the mechanism? Yes, do let me know in the chat section if you want to know the mechanism. Then I will complete this session. If you want to know the mechanism, just do let me know in the chat section. See the mechanism. Everyone, see the mechanism why these three compounds are going to form the same compound. CH double bond O, CHOH, CHOH whole thrice, CH2OH. We know very well that we are going to react with phenylhydrazine. Then what will we get? If I am reacting with phenylhydrazine 6,6H5 NH2, water will eliminate out. Water will get eliminated out and you are going to get CH double bond CH OH CHOH whole thrice CH2OH NH C6H5. This is known as glucose hydrazone. Glucose phenyl hydrazone. Now one more mole of phenyl hydrazine will come. It will react with this compound. Phenyl hydrazine will react with this compound C6H5 NH NH2. Let's see to it what is going to happen. So it is going to react with this hydrogen, it will form ammonia. See to it, this H plus will eliminate out, this nitrogen negative will eliminate out, it is going to form ammonia. And now see, this nitrogen positive will react with this hydrogen negative and this will form aniline. This will form aniline. Now it is undergoing oxidation. Here negative, so positive, here positive, so negative, they will form a bond, and what you will get? You will get compound like this, CH double bond, C double bond, CHOH whole thrice, CH2OH, and you will get, definitely you are going to get NNH, C6H5, and here the double bond O, and once again it will react with one more mole of phenyl hydrazine. See, it is going to react with one more mole of phenyl hydrazine NH2. So what we are supposed to do? We have just to remove out water. We are supposed to remove out this water, and you will get CH double bond C double bond CH OH whole thrice CH2OH. Now NH C6H5 NH C6H5. So this is the mechanism. This is the mechanism. So why glucose, fructose and mannose? Because mannose is getting differing at this carbon and fructose also differing at second carbon only, and second carbon is consumed in this reaction. So either you can say it is Osazone or you can call it dihydrazone. Also you can call it dihydrazone. Dihydrazone. Gene has converted to zone, phenyl hydrazine. So this is all about each and everything I have told you about carbohydrate chemistry, biomolecules, because rest of the things, proteins, amino acids, they already you must have done in your biology. So this I have told you. Wow, Archana, Ashok ji, fantastic. So welcome to you. So this is all about. So are you able to understand? Are you able to understand each and everything about carbohydrate? This reaction was missing, and this I have told you why the side products are water, ammonia and aniline, and they are going to ask how many phenyl hydrazines are getting consumed during this reaction. So all the best. I want to tell you the most important thing, that each and everything of this carbohydrate chemistry is very, very important, and the backbone of this carbohydrate chemistry was glucose and fructose. The hero of this chapter was glucose, and once if you are able to understand each and everything about glucose, you will definitely get full marks. Most of the students are getting negative marks in this biomolecules and carbohydrate only. So do let me know in the chat section, and I am going to give you one more question. One question for your homework, the most important question for your homework. I will ask you this question the next turn. Fructose, this is the question for you people. Fructose on reaction with concentrated HNO3, what will you get? This is the question of the day. important for NEET. NEET can definitely ask you, when fructose is reacting with concentrated HNO3, what's the answer? So find out the answer and do let me know in the chat section after the session is over, the comment section, whether to say comment section, just search for it, and do let me know in the comment section. I will wait for your answer. That question of the day is, when fructose reacts with concentrated HNO3, what is the answer? Aditya Dharji, welcome. So all the best. Definitely we will meet tomorrow with the surprise. Okay. So how was the session? Just do let me know in the comment section. Wow, I will wait for this answer. Fructose on reaction with concentrated HNO3. All the best, bachcha log.